Hi, seventh graders. Today we are going to be talking about scale drawings. So first of all, a scale drawing is going to be like a proportional drawing of a figure or a location, which means that the measurements we can use a ratio table then to solve for some missing measurements. So like over here, for example, on the left-hand side, we have a map of Central Park in New York City. Obviously, this isn't like the real dimensions of the park, right? It doesn't fit on a screen or a piece of paper. So what we have then is we have this scale down below that tells us, okay, every 1 inch is equivalent to 0.5 miles. So that means every 1 inch on this map is representing half of a mile or 0.5 miles. And so if I wanted to actually figure out the real length and the real width of Central Park, I can use a ratio table to help me do that. So right now, if we look at this ratio table, I know I'm going to use the scale that it's telling me, okay? It told me that 1 inch is equal to 0.5 miles. So if I put that ratio on my ratio table, notice the top is inches and the bottom is labeled miles. So that 1 inch is equal to 0.5 miles. Now what I can do is I can use that to help me solve and figure out, like, for example, how much 2 inches might represent, or how much, if we look at the actual length here of Central Park, or scaled length, it's 5 inches here. So I want to use my ratio table then to figure out, okay, well, what's 5 inches going to, how many miles would 5 inches represent? So one thing we could do, we could just say, okay, like 1 inch is 0.5 miles, and we could go direct, we could just count up and say 2, 3, 4, 5. We could also actually go straight to 5 inches and figure that out as well. So we're just going to look at a couple of examples here. And again, we're going to use the scaling technique that we used with our equivalent fraction ratio tables. So you're going to look for example here, if 1 inch is 0.5 miles, okay, if I'm doubling my amount of inches, then I'm going to double the amount of miles. So we could say 1 times 2 is 2. Now, if I take 0.5 times 2, or if I double half of a mile, that means that 2 inches would represent 1 mile. And then we can continue on doing that, looking for those consistent relationships. Because we're now just talking about ratios, it's okay if there might be decimals. Obviously, there's a decimal, and the 1 inch being 0.5 miles. So for example, if 1 inch to 3 inches, I'm scaling up by 3 now. And so I want to scale those miles by 3 as well. So 0.5 times 3 would give me 1.5. Then I can also now notice, okay, I'm scaling up by 4. So if my inches are scaled up by 4, I want to scale my miles up by 4. And so 0.5 times 4 would give me 2. And if I scale up my inches by 5, I want to make sure I scale my miles by 5, which would give me 2.5. So that means the 5 inches that's represented on this map, in real life, the actual length there then is going to be 2.5 miles, okay? So the actual width of Central Park, all right, up here we have 1 inch width. And so I can use my ratio table. My 1 inch is half of a mile. So the real actual width of Central Park is half of a mile. My actual length of Central Park, notice I have, that's 5 inches. So I'm going to look on my ratio table. 5 inches is going to be 2.5 miles. Now, for these next two, we're kind of going to be recalling some other information. So to figure out perimeter, perimeter is the distance around an object. So that's some important vocabulary. Distance around an object. And you can figure that out by adding up all of your sides. So if we think of Central Park here is a rectangular shape, and if the actual length is 2.5 miles and the actual width is half of a mile or 0.5 miles, I can add up all of my sides here to figure out my perimeter, my actual perimeter of Central Park. So when I say actual, we're talking about the real life thing, okay? So if I add up all of these sides, when I look at this, I know that half a mile plus half a mile is going to be 1, and I know that 2.5 plus 2.5 is 5. So 5 plus 1 means that my perimeter here would be 6 miles. And then for actual area of Central Park, now we're also going to kind of be reviewing the area of a rectangle. So again, it's a rectangular shape. Our area formula for a rectangle is length times width. So the length of Central Park is 2.5 miles. The width is 0.5. And so then when I multiply those together, and remember we can use calculators to help us, but if we're typing it, we should write it, and the calculator is only as smart as the person using it. So 2.5 times 0.5 is going to be 1.25 square miles. So when we, or miles squared is another way to write that. Sometimes you'll see it written like that. So the actual area of Central Park is 1.25 miles. All right, so we're going to look at a couple more examples. So this is in your workbooks, page 57, I believe. Okay. So the distance between two cities on a map is 3 inches. The scale of the map is 1 inch. 1 inch is equal to 30 miles. And so we can use that ratio table. So inch and miles. All right, so I'm always going to start with the scale that they give me. So right now I know that 1 inch is 30 miles. And I'm trying to figure out what 3 inches would be. Now, if we wanted to do the numbers in between, we could. So I could say what 2 inches might be and then figure out 3. I could also just go straight to 3, okay, and look for how I'm scaling that ratio. So here I notice that I'm scaling my inches by 3. So I'm multiplying by 3. And so I could do the same thing to my miles. And so if I scale my miles by 3, 30 times 3 is going to be 90. So that means that the actual distance is going to be 90 miles. All right. Number 2, the length of a wall on a scale drawing of a room is 6 inches. The scale of the drawing is 1 inch is equal to half of a foot. So I want to figure out the actual length of that wall. So again, we're going to start with a ratio table. So I know that 1 inch, again, I'm going to use that scale that they tell me. 1 inch is 0.5 feet. And then now I want to figure out what 6 inches would be. Again, I could figure out 2 inches and then 3 inches and go from there. Or I could go straight to 6 inches. Actually, we're gonna do 2 inches first, and then I'll use that to help me figure out 6. All right, so 2 inches, if I double the amount of inches, and I can know that I can double the amount of feet. So half of a foot doubled would be 1 foot. So 2 inches is going to be 1 foot. So then what I might notice is that Okay, well, 2 inches scaled up by 3 gives me 6. So 1 times 3 means that 6 inches would represent 3 feet. So then the actual dimension here is 3 feet. Number 3, it says, what are the actual dimensions of the parking lot? So here, again, would be another good use of a ratio table. I'm going to look at my scale. 1 inch is 200 feet. And I'm going to always start with the scale. Okay, so that information that we're given. So I know 1 inch is 200 feet. So I have a couple of different things that I need to find here. I need to be able to find the actual width, which is going to be 1.5. That 1.5 inches, I need to know what that represents. And I need to be able to figure out 5 inches as well. Okay, and so again, we could do this in a variety of ways. So it might be easiest just to figure out our 5 inches first. Okay, so if we scale up our number of inches by 5, then I can scale my number of feet by 5. So 200 times 5 would be 1,000. So 5 inches is going to represent 1,000 feet. Okay, and then to figure out this 1.5, you have a couple of different options. I could just say, okay, well, 1.5 inches and do a connection like that. Another way I might do it, I'm just going to show you a different way. Let's say I found 3 inches, okay? So if I scale up my inches by 3, I'm going to scale my feet by 3. So 200 times 3 would be 600. So if 3 inches is 600 feet, now let's look at that 1.5. Well, 1.5 is half of 3. So now I'm dividing 3 by 2. So if I divide 600 by 2, I can figure out that 1.5 inches is actually 300 feet. So I have 1,000 feet by 300 feet. Okay, now where I have these questions with the perimeter and area again. Perimeter, remember, is the distance around an object, okay? So if I want that actual distance all the way around, you can think of like walking around that parking lot. Okay, so if I walk from here to here, I would actually be walking 300 feet. From here to here is another 1,000. From here to here is another 300. From here to here is another 1,000. So we can go ahead and add up our 300 plus our 1,000 plus our 300 plus our 1,000. And here you can use the associative property. So you can group different numbers together. You can use the commutative property and add in a different order. A lot of students may add up the 2 lengths first to get 2,000, and then add the 2 widths to get 600, and get that overall perimeter of 2,600 feet. All right, and then the actual area. So again, if I'm talking about the actual perimeter or actual area, I want to know the real thing, okay? So to figure out the area, since this is a rectangular shape, area of a rectangle is length times width. And so I'm going to go ahead and we're going to do 1,000 is my length times 300 is my width. And if I multiply those, then I'm going to get 300,000. And with area, we label that as square feet. Number 6, Hani walks on the sidewalk around the outside of the park for exercise. If he walks 3 times around the park, what is the total distance that he walks? So again, you can use that ratio table to help you. I'm going to go ahead and pause the video, but these notes will be available online as well. So again, you can use this video anytime you need a little refresher on how to use those scale drawings to find actual measurements.